Yes, am I audible? Martin and Humed, only 2 students have joined. So I'll start the class anyway. It's their loss who is not joining, because I'll not be repeating any of these topics in the class for whoever is missing any topic. Okay, so see, as I told you, I'll be starting with thermal units. So the chapter that we'll start with is thermal properties of matter. All right. Now, in thermal properties of matter or kinetic theory or thermodynamics, in this entire unit, we discuss about heat. So that's why I'll start with heat very first. Because heat is such a basic topic for thermal physics that if you are not thorough with the topics of, or not thorough and clarified with the topic of heat, you'll not be able to correlate things later. So heat is what? When we are talking about heat, you have to understand what is meant by heat. Now, see, I'll give you an example. Firstly, you have to understand what is meant by internal energy. Whenever we say internal energy of a system, suppose this is a container I have taken and I have filled it with some molecules. Some molecules are there, though this concept will come again in kinetic theory in detail, but let us assume I have taken and filled this. Now, what are all the possibilities of the total energy in the system? Internal energy is what? Internal energy is the system is sum of all the energies. Sum of all energies in your system is basically known as the total internal energy of that system. Now, when we are talking in physics or chemistry, specifically at this level, class 11th or 12th level, we usually refer to kinetic energy and the potential energy. Fine. Though there are so many energies as well. You have entropy also, you'll be studying. You have another form of internal energy. There are so many energy which are already present in your system, but we'll be just focusing on these 2 types of energies: kinetic energy and focus and potential energy. Now, when I'm talking about kinetic energy, let us focus more on kinetic energy this time. Let's say when I'm talking about it, let's say total kinetic energy when I'm talking. Just understand this concept. This concept, if you have understood this first class, that's why I'm saying it's very beneficial and good that you both have joined the class, because I'll not be repeating and all the basics will be lost. So total energy, when I'm saying total kinetic energy of the system. So in this also, see, if this particle is present, there is a possibility that particle is moving like this, it is moving like this particle is moving like this. So because of this, you will be having in your system a translational energy. Translational kinetic energy. Then there is also a possibility that these particles, they are rotating like this. The particles are rotating like this, which is the rotational kinetic energy. Fine. And there is also a possibility that these particles, while moving, they are not moving as such. They are just moving slight, which a better term to use is vibration. They are vibrating at the point, that slight movement like this. This is also a possibility. One is they are moving forward, backward. One is they are rotating. One is they are vibrating. So you will get vibrational kinetic energy in your system. These are the types of energies. Now, why did I say let's focus on kinetic energy? Because see, whenever in your system, always remember, and this is very helpful for further also for your competitive exams also, you should be aware of this. Whenever we are talking about temperature, so remember, kinetic energy is a function of temperature, while potential energy is a function of force. That's why whenever we were studying gravitational potential energy or any sort of potential energy, I always told you that count the number of interactions. When we were discussing gravitation, all of you have done gravitational potential energy. There we discussed this only, that how many forces are acting. Which force is being exerted, which two bodies are able to exert force on each other. If you all remember, there was a question we did where a square was drawn and the masses were kept at the corners of the square. Remember, so I asked you all what is the maximum number of forces or interactions possible. Most of you said 4. The answer was 6 because diagonals were also interacting. If you all remember, this we have already done. So what did we do? We checked the forces which are acting. In kinetic energy, you have a formula also we'll be seeing here in this lesson, that we talk about the temperature. Temperature will relate. While potential energy means interaction. Conservative interaction. That is the force. All right. So this is internal energy of the system. So internal energy, when I'm saying kinetic or potential, so right now what will I say? What did I tell you? Kinetic internal energy of the system. This is potential energy plus the kinetic energy. All right. But here, right now, I'll be focusing kinetic energy. I told you that kinetic energy is existing. There is a property. We haven't done no kinetic theory. If anyone has done, anybody has any idea about this? Just a second, class. Yes, see, so when there is internal energy in your system, we haven't discussed kinetic theory of gases. There is a postulate which says that for ideal molecules, we consider only the potential energy. We take the potential energy of the system. All right. This we'll study in kinetic theory also. Now, what was the point of this entire internal energy? What was the point of this studying this entire internal energy? I was studying thermal physics. We were studying thermal physics. We started with the concept of heat. Then why was there a need for internal energy? Now look. Now understand this slight concept which will cover entire portion of your heat. Suppose, let's say I have a container. Here also I'm having a container. I have filled it with molecules. I filled it with molecules. Let's say total internal energy. Now I hope you are understanding when I'm using the term internal energy. That means the kinetic and potential energy. Let's say this is some 5 joules initially. And this is having energy, internal total energy as 3 joules. This is the initial case. Then what happens? A small portion of this total internal energy of the system, which is comprising majorly of the potential energy, some of it travels from this container to this container. There are methods for traveling. I have connected them. So some amount of energy has traveled. Let's say 1 joule has traveled. 1, 2, 3, 4, 5. Learn it like this. 5 were there, 3 joule. Though this is not a representation, this is just for study purpose. Now 1 joule has gone from here. So 1 joule has been added. Now see what will happen. From here 1 joule has gone. It is having 4 joules. It is having also 4 joules because of addition. Minus 1 from here, plus 1 from here. 4 joules. Now there is no need for motion. This is also having 4 joules. This is also having 4 joules because of this transfer that occurred. Now class, the amount of energy, that transferred from one body to another body in order to maintain the temperature, in order to maintain the energy, in order to conserve it, this quantity is known as heat. This is known as heat. We have been just studying heat as temperature. No, this quantity, this is known as the heat. Initially, what happened? Basically, through this, you understand that initially energy in this was greater, but finally both are equal. So until and unless energy in A container is equal to energy in B container, let's say this is A, this is B, the amount of heat that will be flowing is known as, the amount of energy that will be flowing is known as heat. So the thermal energy of a body is the total kinetic energy. Thermal, I told you temperature is related to kinetic energy. And heat, what is heat? Heat is the energy that is transferred from one body to another due to temperature difference between the two bodies. I hope I'm clear to all of you regarding this. This is not very difficult to understand, heat concept, but it is very basic because this concept of internal energy is not clear to most of you. Also, let me tell you one thing. Here you have understood before we start with temperature. This condition, no, when the temperature is equal, suppose this was a container and this was another container, and here heat traveled because this was having a higher temperature, this was having a lesser temperature, until both the temperatures are same. You can see no then further heat flow occurs. No flow of heat occurs. This condition, when no flow of heat occurs, this is basically known as thermal equilibrium. Clear? We'll be just using the term thermal equilibrium. That's why. Otherwise, this is not a tough term to remember. Write it down. I'll discuss with you the concept of temperature in detail. But first, write down all these properties. Now we'll be discussing about the concept of temperature. So temperature, what is meant by temperature? Temperature basically tells you the degree of hotness or coldness, which decides the direction of flow of heat. All right. Thermometry is the branch of physics that deals with temperature. So we are not going into the details of thermometry, but you have the principles of thermometer in your syllabus. So we'll be discussing about it. So what is the principle of thermometer? That all the observable quantities that are changing directly proportional to temperature, that we'll be discussing. Volume of mercury, according to the volume of mercury, it's mercury thermometer. According to the pressure, volume, resistance, you have different types. So volume of mercury is the mercury thermometer, which we usually use. Pressure, one constant pressure thermometer, constant volume thermometer, and resistance thermometer. This we usually do not use, but these types of thermometer exist. Now, calculation of thermometers. See, how will you calculate? Look, some temperature X, let's say this is some temperature X, which I don't know. For any particular thermometer, you have Celsius scale, you have Fahrenheit scale, you have Reaumur scale, you have Kelvin scale. All the lower freezing points and upper freezing points will be used. So let's say we have some X temperature. I'm not defining the particular scale right now. We'll be discussing the scale. So first you subtract from that temperature, that particular temperature, the lowest fixed point. This is the lowest fixed point of that temperature. A scale has an initial point and a final point from which the scale starts and from which the scale ends. Correct? So this is known as, this one is known as here. This is the lower fixed point. Every scale will be having one upper point, one lower fixed point. Then you have upper fixed point minus lower fixed point. Upper fixed point minus lower fixed point. This is constant. All right. So first let us talk about Celsius scale. In Celsius scale, you have lower fixed point as 0 degree. And what is the maximum value? 100. So number of divisions means this lower part. Upper minus lower will be 100 minus 0. That is 100 division. Regarding Fahrenheit scale, lower fixed point is 32 degree Fahrenheit. Upper fixed point is 212 Fahrenheit. All right. So difference will be 180 division. Why am I saying to remember these number of divisions? Because you will be then subtracting and you will be wasting your time. Instead, if you remember these values, see 100, 180, these are easy to remember. Then you have the Reaumur scale. In the Reaumur scale, up lowest fixed point, this is 0 degree. And upper fixed point is 80 degrees. So 80 minus 0, 80 is the division. Then you have Kelvin scale. Upper fixed point is 273.1. Fine. Then lower fixed point you have at, lower fixed point you have as 273.15. Kelvin scale you must be using also in your calculations till now. This is a lower fixed point. 273 we generally take for the calculations, but exact accurate value is 273.15 Kelvin. And upper fixed point is 373.15 Kelvin. Though when you will take the difference, it will be 100 division. So see, ultimately all the scales, if I'm telling all of these are constant. So let's say some temperature is there at Celsius scale minus lower fixed point. This is minus 0. Fine. Divided by their difference is 100 is equal to, let's say temperature on Fahrenheit scale minus fixed point is 32 divided by their difference is 180 is equal to temperature Reaumur minus this is lower fixed point, this is 0 divided by 80 is equal to, this is equal to temperature and the Kelvin scale minus 273.15 divided by 100. This you will be using. Now in your question, one of them will be missing and the other will be given. So you can just equate. Suppose Fahrenheit is given, Celsius is missing. So just use this portion of the table. You will get the value of Celsius scale. I'll show you a question also. First, write down the concept of thermometry, all the upper scale, lower scales, then we'll discuss a question also. Start writing it from here. Wherever you get stuck while writing, everything is written on the screen. Ask me in between. Start writing from here. Concept of temperature. Have you written till here, all of you? Just text me in the chat column once. All those who have written or still are writing, just update me. You all can leave now. Tuesday, same timings. We'll continue from here. Questions we'll discuss. Okay. Thank you so much. You can start leaving.